Today, we are diving into something that is a huge leap forward in the world of AI, specifically for online advertising. We're looking at a paper from Meta AI that introduces a framework called Lattice, and it completely redesigns how ad recommendations work at a scale that is almost impossible to imagine. So let's jump right in and see how they pulled it off. Have you ever really stopped to wonder what's going on behind the scenes with the ads you see every single day? It's not just one simple algorithm. It's this sprawling, unbelievably intricate system. But what happens when that system just gets too big, too expensive to keep improving? Well, that's exactly the problem Meta was facing. So here's the fundamental problem. The old way of doing things involved literally thousands of individual AI models, and each one was kind of stuck in its own little world. It was getting incredibly expensive and super inefficient. The goal, the new way, was to move to a single unified system where all these models could actually work together, share what they've learned, and become way, way more effective. Okay, so to make this happen, Meta was staring down three massive hurdles. And we're not talking about small tweaks here. These are fundamental challenges that get in the way of making these huge recommendation models actually work in the real world. All right, first up, economic scalability. You know, the famous scaling laws in AI basically say that bigger models perform better. That's great. But when you have thousands of models, the cost of the infrastructure to make every single one bigger is, as the paper puts it, prohibitive. You can't afford to do it anymore. The second hurdle was data fragmentation. These large models are incredibly data hungry, but by keeping the data sets for each type of ad separate, they were basically building artificial walls between them. The models couldn't learn from each other, they couldn't get a complete picture of what users actually liked across all these different products. And the third big one, deployment constraints. I mean, think about it. In a live environment, ads have to show up in milliseconds. So you've got this huge tug of war, right? You want these super smart, complex models, but they also have to be lightning fast. And that strict speed requirement was becoming a major bottleneck on performance. So facing these three massive problems, Meta's answer wasn't just, let's build another model. No way. It was a completely new blueprint, a fundamental rethinking of the entire system that they call Lattice. And this is what they describe as a model space redesign. So what exactly is Lattice? Well, you can think of it as a framework that goes to war with those three core problems we just talked about. It unifies the models to slash costs, it consolidates data to tear down those silos, and it makes knowledge sharing possible so that every single prediction gets smarter. The goal is simple but huge. Get massive improvements in both ad quality and cost efficiency. And this quote from the team just nails it. This wasn't about small, incremental improvements. This was about fundamentally changing the entire approach to the problem, moving from just trying to make individual models bigger to redesigning the whole space that they operate in. So, how does Lattice actually pull this off? It's not one magic bullet. It's a whole toolkit of really clever solutions, all designed to work together perfectly. Let's take a look at the key components. The first tool is called Lattice Zipper. Now, this thing tackles a really tricky issue in advertising called delayed feedback. Think about it. You see an ad, but you don't actually buy the thing until like a few days later. If you use a short time window for your data, you get fresh info, but you miss that purchase. If you use a long window, you catch the purchase, but all your data is stale. It's a classic trade-off. And this is just a brilliant way to picture the solution. Instead of training a bunch of different models on different time windows, Lattice Zipper intelligently zips them all together into a single unified dataset. It perfectly balances that need for fresh data with the need for correct, complete data, all in one elegant stream. Okay, so you've combined all this data. Awesome. But now you have a new problem, a huge one. You have tens of thousands of potential features you could use, but you can only afford to use a few thousand. So how in the world do you pick the absolute best set that works perfectly for every single ad portfolio all at the same time? The solution is Lattice Filter. It's an algorithm that finds what's called the Pareto optimal set of features. Now, that's a mathematical concept, but it basically means finding that perfect sweet spot, the set of features that gives you the best possible performance across all your tasks without making any unfair sacrifices. Now, this is where it gets really cool. Check this out. Each one of those dots represents a potential feature, and it's plotted based on how important it is for two different tasks. The algorithm goes through and finds the features on that outer curve. That's the Pareto frontier. Any feature on that line is a point of perfect balance, where you literally can't improve performance for one task without hurting another one. It's an incredibly smart way to guarantee fairness and quality for the whole system. All right, so you've zipped your data, you've filtered your features. Now you need the engine that can actually run it all. And that's where lattice networks come in. These are these powerful, unified models that are specifically designed to process all sorts of different data types. We're talking text, numbers, sequences of user interactions, all inside a single architecture. Now, one of the most clever parts of this whole thing is how Lattice solves that classic speed versus power problem. It uses this brilliant teacher-student system. You have a massive, super powerful teacher model working in the background, just crunching numbers and pre-computing valuable insights. Then, the smaller, much faster student models, the ones that actually serve you the ads, can just ask that teacher for its knowledge in real time. So you get the wisdom of a giant model with the speed of a tiny one. So that's all the theory, but did it actually work? Let's get to the results because honestly, they are seriously impressive. We're talking major wins across the board: better performance, faster delivery, and cheaper to run. First up, the big one for the business. After deploying Lattice, they saw a 10% gain in revenue-driving top-line metrics. Now, for a company the size of Meta, a double-digit improvement like this is almost unheard of. We're talking billions of dollars in impact. And here's the thing, it wasn't just about the money. The ads also got better for us, the users. They saw an 11.5% improvement in user satisfaction. This shows the system was actually serving more relevant and helpful stuff, not just more ads. Now, remember that first problem we talked about, the insane cost of scaling? Well, check this out. Lattice delivered a 20% savings in computing capacity. It got all those amazing performance gains while actually becoming significantly cheaper to run. I mean, that's the holy grail of system design right there. And the wins just keep on coming. A 6% boost in actual conversion rates, which means people were actually following through on the ads more often. In their tests, it beat out 10 other state-of-the-art models. And it even achieved up to 1.3 times the hardware efficiency in large-scale training. So what's the big takeaway here? It's that by taking a step back and redesigning the entire model space, instead of just tinkering with individual models, Meta unlocked this incredible win-win-win scenario. It was a win for the business, a win for the users, and a huge win for the bottom line. And that really leaves us with a huge question, doesn't it? This whole project shows that sometimes the biggest gains don't come from just making the AI bigger, but from making its environment smarter. So if AI can get this much more efficient just by redesigning its own workspace, what other incredible leaps in performance and efficiency are just waiting to be discovered?